Hi everyone! So I want to talk about logarithms with base b today, and we'll get to evaluate some as well and be able to convert them from log to exponential form. Okay, so let's get started. First let's write down what we need for our theorem. We need b to be a positive number. We also need x to be a positive number, and b cannot equal 1. Alright, so if I have there is a number y. There is a number y such that, so ST is the abbreviation for such that, we have log base b of x is equal to y if and only if b to the power of y is equal to x. All right, so let's observe what's happening here. This b is your base. All right, so b is your base. Let's see, and y is going to be your exponent for your base b. X is the result of your b to the power of y. All right, so x is the result that comes. So let's look at an example here. So if I have log base of 8 is equal to 3. Now what this means is that my base 2, this is our base right here, base is 2, my x is equal to 8, my y is equal to 3. Alright, using the theorem that we have with logarithms with the base b. Alright, now we've got, so 8 is the result I get when this base is raised to the power of 3. So now let's rearrange this into the exponent form that we have over here. So that exponent form is now going to be, so b is 2, y is 3, so it's 2 cubed is equal to 8. This is by the theorem, and yes, this is a true statement because 2 cubed is equal to 8. 2 times 2 times 2 is equal to 8. Right, now let's look at another example. Now let's say we want to look at an exponent, and from exponential form to logarithm form. From exponents to logs, we've got, so let's say we have 27 to the power of 1/3 is equal to 3. Okay, so we have a rational exponent. So 27 to the power of 1/3 is equal to 3, and then they want you to change it into a logarithm. So 27, following what we have here in our theorem, b to the power of y is equal to x. All right, so we can already establish that this b over here, this is equal to b, 27 is equal to b, 1/3 is going to be our y, and then 3 is our x. So let's rearrange it into the form that we have over here, log base b of x is equal to y. Okay, so I'm going to have, right, so this transforms into log of base b, which is 27, and then we have it of 3 is equal to 1/3. All right, this would be the transformation. So this would be our final answer. All right, now if we want to evaluate, right, so I'm going to scoot down. So let's look at an evaluation problem. Let's say we want to evaluate log base 3 of 243. Right, so what is the answer that's going to result? So based on our problem over here, log base b of x is equal to y. All right, so I'm looking for y in this instance, and y is the power that the base is raised to. So the base is 3, so here we can conclude. So b is equal to 3, our base, from looking what we've got up here. Our x is equal to 243, and y is our unknown. Okay, so let's go ahead and transform it. First things first is when you want to evaluate a log, is transform it into the exponential form. Right, so when I change this into the exponential form, b is 3, so that's 3, to the power of y, which we don't know, is equal to x, which is 243. Now, by the rules of exponents, we know that we have to have the same base for us to solve this. Okay, so if I have to have the same base. I have 3 to the power y. If I change the 243 to a base of 3 instead of the current base that it has, which is 243, I can solve this out. So let's go ahead. So 243, first off, is that divisible by 3? Okay, so we have 243. Now, our goal is to get the same base. Okay, so we have 3 to the power of y, 243. Okay, so let's get the same base. Let's see, does 243 also, can I get a 3 out of there, basically? Does it have a factor of 3? So 243, you can make a prime factorization tree, if that helps, or a factor tree of some sort. Well, 81 times 3, choose any two numbers. We already have a 3 that goes into 243. 81 is 9, and then this breaks down into 3 and 3, and then 9 also is, we have another 9, so that's 3 and 3. So we have a total of 1, 2, 3, 4, 5 3's that go into 243. So if I come back here and start to work on 3 to the power of y is equal to 243, well, now we can say 3 to the power of y, that stays the same. 243, this is the same thing as it being equal to 3 to the power of 5. So now I can say 243, that's equal to 3 to the power of 5. Now I have the same base, right? Now this is something I can work with, okay? So we have the same base, and by the exponential rule of solving for exponentials, we said that if we have the same base, then you can just take the exponents and set them equal to each other. So by the exponent rule, you now have y is equal to 5. And then you will have solved your logarithm problem. Log base of 3 of 243 is equal to 5. So y is equal to 5.